Welcome back to a new session of the MOOC on Information Security, Message Authentication. This module describes the authentication of message and how to ensure the integrity of message being transmitted. From this module, a learner is expected to achieve the following: understand the concept of message authentication, understand the importance of message integrity, familiarize the concept of message encryption, get an idea about MAC and MDC, and learn about the process and limitations of MAC. Message integrity. During secure communications, message integrity describes the concept of ensuring that data has not been modified in transit. This is typically accomplished with the use of a hashing algorithm. Message authentication. Message authentication is a property that a message has not been modified while in transit and that the receiving party can verify the source of the message. Message authentication can be provided using the cryptographic techniques that use secret keys as done in case of encryption. Authentication requirements are: revelation. It means releasing the content of the message to someone who does not have an appropriate cryptographic key. Analysis of traffic. Determination of the pattern of traffic through the duration of connection and frequency of connections between different parties. Deception. Adding out of context messages from a fraudulent source into a communication network. This will lead to mistrust between the parties communicating and may also cause loss of critical data. Modification in the content. Changing the content of a message. This includes inserting new information or deleting or changing the existing one. Modification in the sequence. Changing the order of messages between parties. This includes insertion, deletion, and reordering of messages. Modification in the timings. This includes replay and delay of messages sent between different parties. This way, session tracking is also disrupted. Source of refusal. When the source denies being the originator of a message. Destination refusal. When the receiver of the message denies the reception. Functions of message authentication. The two functionality levels are lower level and upper level. The lower level can be described as: at this level, there is a need for a function that produces an authenticator, which is the value that will further help in the authentication of a message. In the higher level or upper level, the lower level function is used to help receivers verify the messages. All message authentication and digital signature mechanisms are based on the authenticity of messages. These message authentication functions are divided into three classes. First one is message encryption. While sending data over the internet, there is always a risk of a man in the middle (MITM) attack. A possible solution for this is to use message encryption. In message encryption, the data is first converted to a ciphertext and then sent any further. Message encryption can be done in two ways. Symmetric encryption is the first method. Say we have to send a message M from a source P to destination Q. This message M can be encrypted using a secret key K that both P and Q share. Without this key K, no other person can get the plain text from the ciphertext. This maintains confidentiality. Further, Q can be sure that P has sent the message. This is because other than Q, P is the only party who possesses the key K, and thus the ciphertext can be decrypted only by Q and no one else. This maintains authenticity. Symmetric encryption is shown in the figure. The next one is public key encryption. Public key encryption is not as advanced as symmetric encryption as it provides confidentiality but not authentication. To provide both authentication and confidentiality, the private key is used. Message Authentication Code or MAC. A message authentication code is a security code that the user of a computer has to type in order to access any account or portal. These codes are recognized by the system so that it can grant access to the right user. These codes help in maintaining information integrity. It also confirms the authenticity of the message. Hash function. A hash function is nothing but a mathematical function that can convert a numeric value into another numeric value that is compressed. The input to this hash function can be of any length, but the output is always of fixed length. The value that a hash function returns are called the message digest or hash values. Message Authentication Code or MAC. MAC algorithm is a symmetric key cryptographic technique to provide message authentication. For establishing MAC process, the sender and receiver share a symmetric key K. The process of using MAC for authentication is depicted in the figure shown here. The entire process in detail is given below. The sender uses some publicly known MAC algorithm, inputs the message and the secret key K and produces a MAC value. Similar to hash, MAC function also compresses an arbitrary long input into a fixed length output. The major difference between hash and MAC is that MAC uses secret key during the compression. The sender forwards the message along with the MAC. On receipt of the message and the MAC, the receiver feeds the received message and the shared secret key K into the MAC algorithm and recomputes the MAC value. The receiver now checks equality of freshly computed MAC with the MAC received from the sender. If they match, then the receiver accepts the message and assures himself that the message has been sent by the intended sender. If the computed MAC does not match the MAC sent by the sender, the receiver cannot determine whether it is the message that has been altered or it is the origin that has been falsified. As a bottom line, a receiver safely assumes that the message is not the genuine. MAC algorithm, sometimes called a keyed hash function, accepts as input a secret key and an arbitrary length message to be authenticated and outputs a MAC. MAC value protects both a message's data integrity as well as its authenticity by allowing verifiers to detect any changes. The MAC is a small fixed size block of data that is generated based on a message M of variable length using secret key K as follows. MAC is also called cryptographic checksum. MAC is equal to C of K and M. Application of MAC. First one is message authentication. In the figure, sender A wants to send message to B via MAC. Then the first condition is to share a secret key K. Sender A calculates the MAC from message M by applying K. Append MAC to the message M. A sends the original message M and the MAC to B. When B receives the message, B also uses K to calculate on MAC over message M. B now compares MAC1 and MAC2. If both are same, B assures that message is not altered during transmission. If it is not matched, it means B can reject the message. The second one is message authentication and confidentiality. It is depicted in the figure. Sender A wants to send message to B via MAC, then the first condition is to share a secret key K1. Sender A calculates the MAC from message M by applying K1. Append MAC to the message M. Encrypt message and appended MAC using key K2. A sends the generate ciphertext message plus MAC to B. When B receives ciphertext, decrypt using key K2. B also uses K1 to calculate on MAC over message M. B now compares MAC1 and MAC2. If both are same, B assures that message is not altered during transmission. If it is not matched, it means B can reject the message. The third one is message authentication and confidentiality, authentication tied to ciphertext. The figure is shown here. Sender A wants to send message to B via MAC. Then the first condition is to share a secret key K1. Sender A encrypt the message and generate ciphertext using key K2. Sender A calculates the MAC from ciphertext by applying K1. Then append MAC to ciphertext. A send appended ciphertext plus MAC to B. When B receives the message, B also uses K1 to calculate on MAC over message M. Decrypt ciphertext using K2 and get original message. B now compares MAC1 and MAC2. If both are same, B assures that message is not altered during transmission, and if it is not matched, it means B can reject the message. Now we will see the importance of MAC. MAC ensures that only receiver can identify the original message. Even if attacker modifies the message M but cannot modify MAC. In case of MAC is modified by attacker, receiver's calculations of MAC will differ from it. MAC cannot modify easily because MAC is encrypted by secret key K, but key is only known by the sender and the receiver only. MAC is one-way function. MAC provides data integrity and authentication both. Also apply encryption and achieve confidentiality. Limitations of MAC. There are two major limitations of MAC, both due to its symmetric nature of operation. Establishment of shared secret. It can provide message authentication among pre-decided legitimate users who have shared the key. This requires establishment of shared secret prior to use of MAC. Inability to provide non-repudiation. Non-repudiation is the assurance that a message originator cannot deny any previously sent messages and commitments or actions. MAC technique does not provide a non-repudiation service. If the sender and receiver get involved in a dispute over message origination, MAC cannot provide a proof that a message was indeed sent by the sender. Though no third party can compute the MAC, still sender could deny having sent the message and claim that the receiver forged it, as it is impossible to determine which of the two parties computed the MAC. To overcome these limitations, we can use public key based digital signatures. The most distinct feature of public key infrastructure or PKI is that it uses a pair of keys to achieve the underlying security service. The key pair comprises of private key and public key. Since the public keys are in open domain, they are likely to be abused. It is thus necessary to establish and maintain some kind of trusted infrastructure to manage these keys. Key management. It goes without saying that the security of any crypto system depends upon how securely its keys are managed. Without secure procedure for the handling of cryptographic keys, the benefits of the use of strong cryptographic schemes are potentially lost. It is observed that cryptographic schemes are rarely compromised through weaknesses in their design. However, they are often compromised through the poor key management. There are some important aspects of key management which are as follows. Cryptographic keys are nothing but special pieces of data. Key management refers to the secure administration of cryptographic keys. The entire key life cycle is depicted in the figure shown here. There are two specific requirements of key management for public key cryptography. Secrecy of private keys. Throughout the key life cycle, secret keys must remain secret from all parties except those who are owner and are authorized to use them. Assurance of public keys. In public key cryptography, the public keys are in open domain and seen as public pieces of data. By default, there are no assurance of whether a public key is correct, with whom it can be associated, or what it can be used for. Thus, key management of public keys need to focus much more explicitly on assurance of purpose of public keys. Modification Detection Code (MDC). It is used to detect modification. It is a message digest that can prove the integrity of the message. The difference between MDC and MAC is that the second include a secret between Alice and Bob. A modification detection code (MDC) is a message digest that can prove the integrity of the message. That message has not been changed. If Alice needs to send a message to Bob and be sure that the message will not change during transmission, Alice can create a message digest (MDC) and send both the message and the MDC to Bob. Bob can create a new MDC from the message and compare the received MDC and the new MDC. If they are the same, the message has not been changed. Using cryptography, we can convert data into hidden form and can transmit over the network. It protects the data in transit and also the data stored on the disk. It is necessary to ensure the integrity of message in transit. Message authentication can be provided using the cryptographic techniques that use secret keys as done in case of encryption. A possible solution for MITM attack is to use message encryption. In message encryption, the data is first converted to a ciphertext and then sent any further. The authenticity of the message is confirmed by Message Authentication Code or MAC. It is a security code that the user of a computer has to type in order to access any account or portal. These codes are recognized by the system so that it can grant access to the right user. These codes help in maintaining information integrity. Hope you understand the topics discussed in this session. See you next time. Bye.